Sir.
Who chose the name nano to define the thing?
Yeah, so again, nano is a Greek word that means dwarf, and I'm not quite sure. The first use of it was by a Japanese material science researcher in the 70s, I think in 1974. I'm not sure on that, but I think so. And he described it as, basically in terms of computer electronics and the material sciences of that, talking about nanotechnology, and the term just sort of took off from there.
Could nanoscale refer to nanometer?
Absolutely.
Or is it 10 to the minus
9.
9, thank you.
Yeah, that is what it means.
Might there be conflict of interest regarding R&D funding versus the risks inherent in the outcome? I mean, could that be possible?
Conflict of interest?
Yeah.
Certainly, I imagine that opportunity is there for just about any form of research.
To water down the risks or ignore them because of future,
Because of so much investment's gone into it?
And because of their future, I mean, if these people are experts in the field, they might, think in terms of, we'll play down the risks because of, possible, lucrative deals in the future concerning nanotechnology. And I'm just wondering if that one in itself would be a conflict of interest.
It could be. It certainly could be. My understanding is that most of the environmental research is not being done by the people that are looking at some of the applications aspects, so that conflict of interest is hopefully separated.
When risks are identified, maybe an example would be the biocide nature of nanosilver and so on like that. What are being done to further study and quantify the risks?
Yeah, that's a great question. What's being done to further study and quantify the risks, especially with things like nanosilver? To come up with some really interesting research. One of them published in the journal Nature was done with our UK partners in how these small deliberation groups on health and energy applications of nano. Do people think about these in different ways? Do they talk about risk in a different way? And even other research that looks at how do men and women think about these issues? Are there different ways of thinking that men tend to talk a certain way in small groups or think about risk in a certain way? How do socioeconomic factors fit into these? How do people of different class scales think about and talk about some of these risks? And then based on that, what kind of policy recommendations can we make? How can we understand what the public's ideas of this are in order to either calm certain things that necessarily might not be risky, that we do have a lot of knowledge about, or raise concern about things that maybe people aren't as concerned about? So again, the challenge for this, how are we supposed to think about consequences before they even happen? Right?
Isn't there a certain kind of bias built in? For example, we talk about the experts. But the experts tell us they don't know. But we call them experts. And then we look at citizens, and we say, well, citizens really don't know. They're not experts. They're just worrying or anxieties or stereotyping. But isn't it true that, for the most part, we don't know very much, that no one knows very much? Maybe that's the starting point rather than using language, as you pointed out. Because language can be used as a tool to deform the truth as well as express it. And by talking about experts when they don't know what they're doing, basically, why do we call them experts?
And I think
you call them experimenters.
You bring a really good point up. What's the role of expertise versus the public in this if there are so many unknowns?
And the use of language.
Language is...
Call people experts when they're...
I see what you mean.
You see what I'm saying?
Mm-hmm.
And citizens who, of course, don't know anything, right? Because they're just citizens. You see, right away, the language that we're using all of a sudden shapes the assumptions and perceptions. And the question is, does it deform the truth or elicit the truth?
Well, what is the truth is a pretty malleable term in my mind. But
I think one should question the language, and to use your words, the words, the way we think and through words is very critical, don't you think?
I think it's a great point. One of the and that's actually a point that I think some of the IRG3 group that's dealing with these social perspectives on this of risk, public perception of risk, is trying to create more and more of a deliberative process in understanding these issues. Not saying, here's what we know or don't know, and let us tell you, and now talk about it. But what does the public think? And so it's becoming more and more of a, instead of a one-way dialogue, a two-way dialogue. More and more sessions where, and Europe is especially good at creating some of these cafes where people get together and talk about their concerns and their issues, and that in turn shapes the types of research or the types of policies that are created, instead of the policies being created and then saying, here's what's going to happen, what do you all think about that? Right? So
give us an example.
Yeah, for example, the Netherlands has a really, really interesting nanotechnology project, and in a number of in one of their institutions in particular, at University of Twente, and they're involved in a lot of these creating these spaces of bringing people in and just having open forums for discussion on some of these issues with some of the researchers, and that in turn helps these researchers think about their own ways of dealing with these issues, these risks, and what are they working on, and having that sort of space for dialogue to really create this two-way process and not just have it be a lecture. Mm-hmm.
Do you know of any survey or a kind of study that just surveys what people, the general public, knows about it, or what they think about, what their imagination is about it, what their concrete knowledge, definition?
I don't know of a survey that when you talk about the public, I mean, who is the public, and how many people do you include?
We're not actually working in these countries.
Yeah.
I was part of that study.
Were you?
Yeah, the UCSB, they paid some of us to we were at the hotel up here, and it was like a 4-hour thing, and then they had us learn different aspects of it, and we chose which aspect we wanted to learn, and then they took our information, and then we kind of had discussion about it, and that was to get what you were saying, to study the public's
perception,
knowledge
yeah,
and ideas about nanotechnology itself. So that was the slide before.
Yeah.
That was part of that.
Oh, that's really cool. The challenge, I think with the challenge of something like that is that maybe there were 50 people there that day.
No, it was really small. But
so less.
Did a bunch of them. So the one that I was participating in probably had maybe 10 people, but they did a bunch of them. So
okay.
They did 5 times. So total they did have quite a few.
So 50 or so. But then is that necessarily a good representation of the public? Like, what do you say is the public with something like that? So that becomes a real challenge for some of these things. And we're trying to actually leverage certain types of technology to get broader and broader audiences. Internet surveys where people sit down and they'll do a 10-minute survey, and we can kind of get a sense of some of the thoughts based on directed questions that are asked, and get thousands and thousands of people to participate in that as opposed to just 50, and across wide ranges.
It just proved the public perception of what they didn't already know that much about. So I didn't really see the point in it, but
yeah.
It really proved it a whole lot, I think.
Well, yeah, some of the research that's come out of that I think is really interesting about how do men and women think about these issues of risk, or new issues that are brought forward that they may not know much about. Which issues do men or women gravitate towards? That also, and how is small group discussion
that has nothing to do with nanotechnology. That's more like study on society.
It could be. It could be. I think it does have something.
Well, it sounds like a lot of, or most of the questions and comments are about potential conflicts of interest and risks and dangers posed by nanotechnology, and it's kind of a subject that I've been interested in for a long time. It seems like it has a whole lot of promise in just about every aspect of society in terms of biofuels and making super efficient solar technology, and in medicine, like the idea of having little nano bots that can act as microscopic surgeons to do really amazing things. But it seems like the root of a lot of these concerns comes down to whether it's how is it that we can have objective and unbiased oversight that really is totally, has the public's interest, fully at heart, and isn't compromised by financial incentives and profits and stuff like that. And I think this is something that we got to figure out as a country and a society when it comes to a lot of things like food production and nuclear power and stuff like fracking and oil production and stuff like that. We don't have adequate public oversight or an ability for the public to really have clear, objective oversight and have proper regulatory protections and protections for the public. And I think that's kind of the central issue that we have to address for a whole lot of technologies that are already, I would say, out of control, so that we can do it for other technologies that are coming down the line that, could have really, astounding benefits.
Yeah, I think nanotechnology is a great avenue for opening up discussions about the role of science and technology in our lives and the risks and the benefits that science allows for us. So I think all the comments you made are exactly right for a number of different types of science technology, and nano just happens to be the way that we can talk about this.
It's like this huge subject umbrella that, if we kind of direct funding in the right way, it could really, accelerate a whole lot of progress extremely quickly. Or, if we let corporations just kind of make profits as easily as possible, as unfortunately is kind of the status quo at this point, then we will end up with nanotechnologies that don't serve the public but serve quick profit instead.
Yeah, there's that.
My question is regarding the medical uses. Does this mean we have to have new training for doctors, or are doctors just kind of going in there and experimenting with these new methodologies, but there's no particular professional oversight of that? Or?
Yeah, for people that might not be able to hear that question, I'll try to repeat questions as they come. The question was, with these possible medical applications of nanotechnology, does that mean that we have to have new training for doctors, or are they just experimenting willy-nilly with some of these? My understanding is that most of the medical uses of nanoparticles today have not yet made it to the medical consumer market. The FDA is still evaluating a number of these uses because, again, this is really cutting-edge stuff. This is pretty new ways of even building nanoparticles that then may be coated in a shell of the drug that you want to have delivered. And for example, you might have a nanoparticle that, when is hit with light, it releases energy. It just explodes with energy, and that process can then release the medicine. So the idea is that you could maybe insert a nanomedicine in a certain area, hit it with a laser beam, and then have instead of having the orally taken or a shot that goes into your bloodstream and there's just medicine going everywhere, it's really targeted. But again, my understanding, and if anybody has any other knowledge about this, is that this is not yet out for the public. But and who knows if doctors then do need to have different types of training? And I don't know enough about the medical field or what doctors do when new pharmaceuticals are available.
Well, mine's more a sort of an observation and a question, I guess, that probably doesn't have a good answer that would satisfy me. Watching this sort of explode in the possibilities of use in so many fields, it seems like, as Dawn had mentioned, with the material sprayed on windows, that all of a sudden the whole home becomes a solar receptacle, and you mentioned about that. It seems to me that it radically changes our entire society, radically.
Yeah, so people that might not be able to hear that, it seems like nanotechnology has such a broad-based technology that it really has the potential to revolutionize the way that we live in multiple ways, good or bad, but to really be revolutionary, transformative. And I would say that I think that's exactly what the federal government was saying when they announced the National Nanotechnology Initiative, that this is moving towards the next industrial revolution. There's a whole separate way of thinking about nanomaterials and nanobots and this sort of thing that's a lot more speculative. But the ideas, the potentials that you could think of why controlling matter at an atomic level, it does. It changes almost everything, including aspects of potentially of human identity. Right? So if we are able to to use technologies in a way that enhance our abilities, does that make us more than human? Right? Are we then, there's one idea that is really, really speculative and pretty far off, but that has to do with the convergence between nanotechnology applications and biotechnology applications and intelligent computers. And that the convergence of these various fields could then allow people to basically become semi-robots, semi-biological organisms, creating the cyborg idea, which is really the singularity is the idea behind this emergence of humans with machines to create something that's more than human. So the very identity of what does it mean to be human, what is human nature, is at the visionary levels is potentially revolutionized. But again, we're getting into really speculative terms there.
They're already doing food.
It's genetically engineered food, so it's a new organism that humans are. Some researchers and humanists are now calling this era that we live in the Anthropocene, where we had the Pleistocene era and the Paleolithic era. The Anthropocene is basically the era of Earth's existence, and where humans are basically the major influences on the planet and in control of evolution. That we're no longer subject to the laws of nature, we're shaping nature as we know it, and creating our own laws. And biotechnology, I think, is part of the cutting edge of that. And nanotechnology is it's a platform of manipulating matter at the scales of DNA. So we can consider it along similar lines. But we live in very interesting times.
Okay, so then I'm going to ask a very brief question, for a brief answer. What are the major technical challenges that loom large when we think about going from where we are now to the full promise of nanotechnology? Are there some categories like the ability to place nanoparticles in a specific position? Mm-hmm. I know that's one. What are some? Is that and others, and is that of any interest?
Okay, cool. The question for those who couldn't hear was, are there certain stages or challenges of development for us to get to realize the visionary dreams or the potentials that nanotechnology has? Are there particular technological challenges or hurdles that we need to move forward in order to realize some of those speculative visions? And I know that the National Nanotechnology Initiative considers its progress of nanotechnology in stages. And the first stage is really just controlling and understanding matter and knowing how it works at the atomic level. The next is actually manipulating it and putting it into small mechanized structures. And then the next stage, and this is where things get pretty speculative, is into a systems framework. When we have nano machinery, nanotechnologies, nanoparticles working in multiple different functions to create a broad system of interaction, so that nano is just a part of our human interactions or any kind of interactions we have. So the specifics for how we transfer through those stages, I don't know. And I don't know the science behind it enough. I do know that Richard Smalley, this Nobel-winning chemist, got into a really public and semi-vitriolic debate with one of the visionaries of nanotechnology, whose name was Eric Drexler. And Eric Drexler went to MIT, he got his PhD in MIT, and he actually got it in nanotechnology, but he was not a scientist. He was not a lab practicing a scientist, per se. He just knew the science. In a sense, he was kind of a visionary engineer. He knew how matter should behave at these scales and then considered the possibilities of how we can manipulate it when we do. Drexler was also a really strong component of what he called molecular manufacturing, which was nanobots, right? Creating these nanobots that will swim on our bloodstream, and these sort of Kurzweilian visions of the singularity leading up to that. Drexler got into this argument with Richard Smalley, this chemist who had discovered a nanoparticle, dealt with carbon nanotubes, had a company that he had started basically to produce nanotubes. And Smalley said, "You're really ruining the public image of nanotechnology by talking about nanobots. That's not what nanotechnology is." Drexler said, "I'm the one that really popularized this idea. This is what nanotechnology is. It is about molecular manufacturing." And then it got technical, and Smalley started to say, this isn't possible. What you're talking about, moving atom by atom to create anything from the bottom up, from the very bottom scale to create upwards, as opposed to shrinking things or just continually making things smaller, the atom by atom processes are not possible technically because of what he called the sticky fingers problem. How do you have a machine that can grab an atom and move it precisely where it needs to be, have the bonding happen, and let go of it and place it? And Smalley just said this is impossible. And Drexler maintained that the laws of physics and certain examples of enzymes and nucleic acids that are created the same way that cells replicate and proteins are made and amino acids are made, that those processes of creating from the atom atomic scale up are possible in nature. Therefore, we should be able to do them as humans as well. This is possible. And that debate still, I think there are certain camps, but mostly Smalley won that debate in the public eye. And that's why we consider nanotechnology today, in part, more about the material science and the technological aspects than we do these visionary aspects. So your question kind of opens up a broader historical background, is how do we think about what is nanotechnology, and then does that change what these scales are for where we're going and what the technological hurdles would be to even get there? So, interesting question. All right.
I was just thinking about how, when I graduated with a master's degree in '83, we didn't have PCs then, no internet other than some databases at the university. And where we're at now, what this generation's gone through in terms of these is unbelievable. The internet still just, what's happening, the accessibility of it is beyond comprehension. And yet it's very real, and it's every day, and it's something I can't imagine being without it. And now we have nanotech, a whole new concept. It's the same kind of thing. It's just amazing. And yet, I don't know, we still have wars, and we still have, somehow humanity's kind of just going along and dealing with it all. And
Yeah.
It's just a process, it's just another process. And it's just a very interesting presentation, actually.
Yeah, it's a fascinating topic because it just opens up all these avenues. And are we at the cusp of change? What changes have we already experienced? I mean, I think about cell phones today, right? I just got a smartphone a couple months ago. It's changed my life. I mean, I don't know how to get around anywhere in my head anymore unless I have my phone. My sense of directions are lost without it. My access to information, it's almost like I have to remind myself to use my own brain to think of an answer as opposed to just going, just like, well, the internet will tell me. This external mind, right, that is billions of people big. The information out there is unbelievable. The interesting social questions I think that some of that stuff gets into is some of the developed world countries now consider internet access a human right. Right? This is a human right. Access to information, the ability to have access to information and communication is a human right now. This didn't exist a couple decades ago, and yet we've changed what we understand the needs of humanity are. Like I said, we live in interesting times. And humanity itself, like, what does that mean about human nature? In thinking big scale history, big terms, 10,000 years ago, when humans, for millennia upon millennia, had just wandered around the earth, hunting and gathering, maybe started domesticating animals, first planted seeds, took seeds and planted them, and then waited in one place for them to grow. And that was the dawn of civilization. We didn't have villages. We didn't have permanent places to live before that. We didn't have cities. We didn't have culture. We didn't have written language. We didn't have math. I mean, that was a major transformation in the way that we as human animals, we are animals, lived on this planet. And we've changed the way the planet behaves in part because of it. So I think this internet revolution in these forms of science and technology really can have absolutely transformative implications on our species and on the planet.
Thank you for coming.
Thank you for having me. This is my pleasure.
I, for one, feel that I have to balance my life between technology and being a human being. And I find it the biggest challenge that I have. Because I can spend my whole day in front of my Mac and continue increasing my knowledge. But I also feel that there's different aspects in my life that I want to continue to develop. And when I hear about this, I'm frightened. I realize all the wonderful possibilities, but I'm also frightened about the things that might happen to what we are as human beings, and how in the wrong hands this technology or parts of it could be used for making armies of nanobots that would kill whole populations or whole continents.
They're called drones.
Works with drones. But it's the same idea. So here I am. I'm wondering, and I know that there's no good answer, but I'm fascinated, and I am frightened.
Yeah, I think we all are. And I think that's part of the reason why we're all here to talk about it, to really, how do we wrap our heads around this? And I think the only way we can do that is really with each other, talking to each other about it, and sort of getting some of those fears out there and trying to figure out ways that we can work collectively to mediate some of those concerns. But I think you're right. Yeah, it can be. I think the real question that I keep asking myself is, with these changes, some of which seem inevitable, or some will happen whether I want them to or not, or whether we try to organize against them or not, what gets lost in the change? Right? Like, I mean, I'm the same way. I could spend all day on the internet reading the paper, and I spent 4 hours the other night with a friend in Washington, D.C., talking with him over the internet, and another friend joined in from Boston, and I was in Portland, Oregon. That's just fascinating to me, but I was also talking to people that exist, that are very much a real and a very meaningful part of my life, but not in my everyday world. I wasn't walking around my neighborhood and talking to my neighbors or interacting with people there, real live people. And so even with these opportunities, I think the real question is what's lost, and what's worth not losing.
Yeah, well, I was just thinking relative to risk. Now, from the sociological, everybody would say, well, we should err on the side of safety. Okay, now, if you think back, Einstein developed his math, and from that became atomic energy. And if we had thought, well, this is too risky, we'll err on the side of safety, the Second World War might have turned out significantly different, because we were not the only ones seeking that bomb. Now, at this point in time, there may be some very risky things relative to this technology. But if we don't explore them, somebody else will, as you showed them. Obviously, China's with their economy, and so there may be things that we need to know. There may be mistakes that we need to make before somebody else knows and makes those mistakes. Now, from the humanist side, you say, well, I don't want them to be exploring some drug that might cause a thalidomide type problem. But then on the other hand, how many good things do you not get? How many cancers do you not cure, et cetera, by being risking on the side of safety? And then, like you say, the experts or the experimenters, they don't know. So how am I to know what's safe, and how am I to make a decision? Well, you shouldn't you shouldn't explore that particular part of the biology because X, Y, and Z. I don't see a clear-cut answer for me.
Yeah, I mean, what do other people think? I think that's with the what if questions.
Yeah.
Right, what do we do with that? What if? And those what ifs.
Part of that was sort of we had to kill people to keep people from.
How many people did we save by?
Yeah, and that's I think that's part of the reason why institutes like this exist, is to talk about these issues, to wrap our heads around them together. I think there's something else I want to bring up, because I think this brings up this point about science as a process, and science as happening in social contexts. The same way that love can be just a feeling that it hits you and you don't really control, but what you do with it, how you act, lovingly or not, that how we act with science and the choices we decide to make or pursue or not pursue, that's where I think we do have social control, because science does happen in social context and it has social implications. So, yeah, I think these societal issues are important.
Agree on that.
It's not going to happen. Yeah, a bunch of hands went up with ideas. What was?
I was thinking it's a question of motive, because history has shown that anything that has been can be used for benefit or for destructive purposes. That was even true. The atom bomb was not in Einstein's mind.
Right.
He was a purely thinking mathematician.
Right.
And we see it coming down the line to where now North Korea wants to drop an atom bomb on America. And nanotechnology has at least the same or even higher potential, because I do not know how sophisticated the equipment has to be in order to work at the nanotechnological level, but perhaps not even as intricate as what it would take to enrich uranium, etc., to pull that out. So it's very scary.
Yeah, I think my motive is important.
Yeah.
And uncontrollable unless society or groups of society organize to try to shape it and influence it in ways. Jim, you had your hand up as well.
Joe.
Oh, Joe, I'm sorry.
Sorry. Well, just a quick comment from the analogy about the race for the nuclear advantage between nation states. So once upon a time, it's so easy for us to say, well, we need to find out the potential weapon advantage here because we're the good guys and we need to control that. I'm sure there's a body of people meeting right now in China who are making the exact same argument that they're the good guys and they need to find that out.
Korea.
Yeah.
South America?
We're the good guys.
Yeah, we call it manifest destiny. Kill all people. Because we're the good guys.
They probably call it the same thing.
China doesn't have as much of a warrior history as we do.
Well, let's not get into that. Okay, right now. Steve, did you have a question?
Yeah. I'm a lot more concerned about this than I expected I would be, after just hearing what I've heard in the last hour and a half or so. What I'm concerned about are, is what a lot of other people have alluded to, but I want to take another run at it, and that is the unintended side effects. Already on one of the slides it talked about the carcinogenic implications of some of them. He talked about the long-term buildup implications, which we have no way of knowing yet. And I can picture how this would work out in the United States more, having a good institute like you're associated with. But I was really especially alarmed when you said that it's one of the few institutes in the world that's doing this. And then, so how is this going to work in all the other countries? In Europe, in China, in India, and all the other countries of the world that are doing this, because it seems like it'll just be either controlled by corporations that are driven by the profit motive. To get their new goods that seem really shiny and attractive out to market as soon as they can, and to try and revolutionize society and gain economic advantage. And even in places like China, where the economy is directed by the government, more directed by the government, the governments are going to want economic advantage. And then a lot of the third world countries will see that this is a way of gaining economic advantage for governments and corporations in third world countries to get economic advantage and profit-driven economic advantage if they just rush headlong into it without investigating the unintended side effects and the long-term consequences of that. So it seems like we could be, the analogy that I wanted to use, has to do with the atomic bomb also, but also the atomic bomb in the late 1940s and early 1950s. We were so stupid that people in Nevada and Utah and the South Pacific Islands would go out and watch the atomic bomb explosions for entertainment. And that these were people that 30 years later were dying, because they had no idea about the unintended consequences and long-term buildup of radiation and other things like that. And are we going to be as stupid as to do that too? And it seems like your institute will perform a great function within the United States to be an independent source of information, that's semi-detached from the government, semi-detached from the corporations. But I fear greatly about all the stuff coming in from other countries that don't have such institutes to be such independent sources of information. So how is it going to work with respect to other countries for them not to be exporting their goods where the long-term consequences have not been adequately investigated, even exporting them into this? Gets into the old stereotype about all the, China exporting lead paint-based toys and asbestos-based toys without any regard to the consequences of the health of the people that are going to be buying them. And it seems like we've left the door wide open. And how is this going to work, particularly in terms of other countries that don't have such institutes for independent sources of information?
I think that's a great question. How is it going to? How do these things manifest globally? I think one of the ways that international organizations are trying to deal with this is creating work studies that are really dealing with the nanotechnology issue in particular. So the organization, the OECD, of the Organization of Economic Cooperation and Development, most of the industrialized nations of the world, especially in Europe and North America, are a part of this. And they're in global dialogue about how do we deal with this? What is your nation state doing? What is the best research that you have for a science-based understanding of what these things do and what we should do with your independent national regulatory structures to deal with that? And Europe is frankly ahead of the curve than most of the other members of this. The European environmental regulations on chemicals and toxic substances is really, really focused on the precautionary principle, much more so than the United States' structures that were built in the 70s that really, I think, need a lot of adaptation and aren't ready to deal with nanostructures themselves, particularly in a regulatory framework. The OECD is involved in these discussions. What is Europe doing? How are they defining a nanomaterial at this time based on what we know in order to try to mediate how these things get spread or used, or how workers in factories that are taking opportunities to use these materials are protected? So there is some international organization dialogue that's happening on those very issues today. But like I said, these are things that are still evolving.
But what happens in the other countries that don't have these things?
I think that's a big question. The IRG2 that looks at globalization really thinks about this kind of issues of inequity. that have to do at a global scale.
But are they insulated? I mean, don't Chinese researchers and things, aren't they involved with coming to the U.S. and coming to bodies like that are at UCLA and UCSB?
Yes. Yeah, absolutely. But they're also advancing without the same kind of regulatory structure that we have here or that Europe has there. So the factories per se, the actual workers, the people that are going to be touching and working and dealing with these chemicals that don't know really what their properties are, they just are looking for a paycheck to send to their families out in Western China, those people are maybe at the front edge of this concern. They're at the front line of what do we do with these and how is this going to affect us. But I think that where you started with that question is unintended side effects, right? Yeah. The framework that we try to deal with some of those is what researchers call anticipatory governance. How do we govern these issues? How do we anticipate what kind of governance we need to have in case these whatever what-ifs evolve? What do we know and what can we project is what we think is going to happen, and how should we organize society around that? So that's a whole field of research that is really probably just a decade or so old. Anticipatory governance, in turn, nanotechnology is one of the bigger avenues that is an issue within that field of research.
One other analogy that I wanted to bring up, and that's about the FDA. You know, the Federal Drug Administration insists on having 10 years of tests before they'll allow new medication to be released. And they have 10 years of tests, insist on 10 years of tests, no matter how beneficial a potential medicine is, because they say that it's necessary, absolutely necessary, to investigate the long-term consequences, the long-term unintended side effects of a new substance like that, and also the long-term buildups. So it seems very difficult to get around being able to know what the long-term buildups are unless there's a moratorium on this for a long period of time, for 10 or 20 years, until the long-term consequences and the long-term buildups can be studied.
Yeah. The ETC group is
standard operating procedure for the FDA. And so what kind of procedures like that are being integrated for nanotechnology?
Well, not a lot, frankly. I mean, like I said, a lot of these products are available on the consumer market now. So
that's very concerning then.
I think it is concerning. It is concerning, and even understanding how do we define a nanomaterial gets really challenging, because, like I said, each nanomaterial it can have totally different reactive properties that we didn't expect. We had no idea that it would happen at that scale.
Yeah, no idea.
And even the same material at a 50 nanometer range to a 100 nanometer range can have totally different properties. It's the same chemical. And our regulatory structure in the United States is based on chemical structure. Right? So gold, totally fine. Let it go. It's not regulated in the marketplace. But nano gold may have different properties that we do need to be concerned about. So our regulatory institutions are still grappling, and the FDA is very much a part of that concern and that debate and what to do with it. At the same time, trying to advance the opportunities, the benefits that these materials really do have for increasing human capacity, human life, human ease, human betterment, and making that accessible for solving some of our bigger, broader global challenges that are really, big environmental problems. So these are issues that are a mixed bag, and there is no clear-cut answers for any of them. And the scales that we think about them, the way that nanoscale is what really matters. When we think about the societal scales of things, how is this affecting my community, my day, my family? How does this affect the nation state that we live in? How does this react at a global scale? Scale really changes how we think about the societal implications too. So there's no single shot answer to any of these things.
Can I ask another narrow question?
No. Well, you can after we go around and include everyone,
How would they produce? What's the process for making
There's a lot of, this is where the scientific part of it I don't have the details on, but I know there's a number of different ways to do it. For example, carbon, if you superheat carbon, it will form in a vacuum it will form into a buckyball, a spherical, or into a carbon nanotube. Those then are sometimes then dipped in acid, so that the irregularities of the carbon, the parts that you don't want to use, would then burn away, and you're just left with the pure carbon. And then you can apply that into some sort of experiment or into some sort of technology. But that's just one type. Other types are, there's all sorts of crazy ways. Running a liquid through something and then running an electric current through that liquid, and then that creates a nanoparticle, and then how that gets separated off from the rest of the material, I don't know. These are new ways of being invented and other ways that people have been doing for 20 years. But again, they're all different, and I just don't have the expertise on that.
Maybe destroy
Some, I don't know. The real interesting work, from my interest, is how these things work in nature, in the environment, in ecosystems. And what some of these researchers at Duke University are realizing is that natural processes are changing the way these materials behave than we would have expected in the lab. If you just looked at, and this is the case for other chemicals beyond the nanoscale. Freon, for example, if you looked at Freon and you did lab work on Freon, you would never, it'd be really difficult to extrapolate to a hole in the ozone caused by it, right? But once you release these into nature, they perform and act in ways that we would never expect within a laboratory. And so nanoparticles are also similar, that there are some particles that we would think, wow, these probably are pretty toxic, but what ends up happening is they accumulate together, and they become more bulk scale, and they're a lot more they become much more harmless. Or ways that we thought would be pretty benign, they end up getting absorbed and stunting the growth of plants. So each particle is so unique that I'm not sure that people really know how nature, when they're actually in an ecosystem, will change them or play with them.
Do you have a question, Jim?
Well, just a comment, if I might. Actually, surprisingly to me, I was reminded of the myth of Prometheus. And I was wondering why I was. Because Prometheus in the myth was someone who had tremendous courage and compassion, but he also had foreknowledge. That is, he was able to understand the implications and the consequences of decisions and initiatives that were taken. Now, what is interesting is that he also had a brother who was very good. He was a very good man. But he was Epimetheus, and he always learned by looking back. After the consequences of his decision is when he would learn. And of course, it's because Epimetheus did not listen to what the warning given to him by Prometheus, the foreknower, who can see the implications of decisions made. Because of that, Epimetheus fell prey to a device by Zeus, and ultimately Pandora opens the box that she's not supposed to, and then out of this comes Pandora's box, effect. All these things are released and spread around humanity, and not everyone is subject to it. But of course, the last thing to go out of the box is hope. So there is that element to it. Now, when I took that, I said, okay, what is being said is perhaps we were very naive going back to the 19th century. In fact, many aristocrats were involved in science and so forth, and assumed to be goodwill and so forth and so on. But anyway, if you look at the concept that knowledge is morally and socially neutral, and you put that in a competitive matrix, that's where you generate a lot of problems. And this has created a problem, and we can't reverse it very easily at all. We're now, as so wonderfully pointed out about, we have to individually take responsibility for how we use technologies, and science certainly isn't, and industry certainly isn't, and nations certainly aren't. So now it becomes an individual matter, and individuals in centers like yours, which I think Steve is right on, is so helpful to hear about. It's the element of hope in Pandora's box. But to me, it's just a final thought, is that there's a deeper level here that is, I think, the only way that people can really go in dealing with the waves that are unfolding from technology. Because we've overloaded technology, we're fascinated by it, and therefore we're blinded by it. And that is, as long as we consider pleasure, leisure, and longevity as absolute values, we're going to be subject to the promises, which are often false of technology because they never point out the implications that, Prometheus didn't foresee. So, and once we start questioning that and putting that in a more wholesome perspective, I think we'll lose our fascination with technology. We're going to lose it anyway because when the effects start coming in even more so, we're going to be more sober about it. But it's just some thoughts. To me, this is just an approach. All the points being made are so fascinating and interesting. But anyway, those are just some thoughts I wanted to share.
Does anyone want to pick those up? Those are awesome thoughts. Yeah, I think the Mythic framework, I think, is a wonderful way to really try to deal with some of these, because in some ways that points out that these issues aren't new, right? I mean, that was 2,500 years ago that some of those myths are being at least written down, let alone when they're being discussed. So I wonder if we're going to really ever back off technology, because I think we're tinkerers as a species, and I think we look to use. Yeah, I mean, we are technological creatures. We create technology. We are tool makers. We man the tool maker, and I don't think we'll ever stop unless we just end ourselves. but yeah, there's ways to mediate it for sure.
No, I think that in addition, I mean, we aren't just tool makers. We have a lot of other drives as well, and I could foresee whether it's nanotechnology or biotechnology or nuclear power or whatever. We have so many more ways now that we can help the four horsemen, that I think that it's almost inevitable that one or more of those is going to bite the world in the butt big time. And the question will be, I mean, I think we'll slip back, or some regions will slip back into some sort of dark ages. And then the question is what kind of religions and philosophies come up, and multiple ones will come up, and which of those will socially outcompete the others. Will you end up with Cannibal Leibowitz? Will you end up with Mad Max? Will you end up with a bunch of different visions? And I wouldn't be surprised if some significant segments of the world put a kibosh or just lose the ability to, not that we won't invent new tools or try to recreate ones, but we won't have scanning electron microscopes, and we won't have linear accelerators, and we won't have vast chemical retorts and petrochemical industry.
Nanotechnology opens up an amazing field that not only touches on myth but also speculative futures that we really have no idea about. But it's such a fascinating field because it really is so broad-based, and it is at such a cutting edge of human capacity right now that is only in some ways possible because of the global society that we've created over the past 500 years or so. It's a fascinating, because it does open up, and it also, these visions, these dark visions perhaps, also have to do with this idea of hope. We look back to this myth and that hope is still there, and we could hope that there's something different, or we can try to make that, we can try to work to realize our hope. So it's a wonderful field because it does touch on all of these different really deep parts of who we are as a species.
Next question.
Yeah, I just have a comment that I think that this is an opportunity for us to look at all of our systems that we use, that we depend on to look at new technologies for their input, such as risk, such as environment, just all the things you've been mentioning, and that they're really, those currently are taking very much back seat, not really part of the discussion when a new product about, because a comes out, because it's, in the terms that you've been using today, you're very excited about it, and, many people are, but I think that we need to strengthen the FDA, all of the various regulatory and government people. It's really going to come down to people. I feel like there's been a real kibosh on people speaking out, like scientists. I wish more scientists would be out there talking to us and talking to each other publicly, so that we can hear the conversation rather than just saying, well, what does the public think? And the public really is reflection back on what they've been given, which in my book is pretty thin. So I think it's an opportunity to, as many are, right now we're talking about fracking, and it's like a priority. It's like, well, this is public. This is not public, it's private. You can't hear about this because of the dollar sign, etc. So there's just a lot of things out there that I don't know. We need to change other systems along with this new technology as others come along. The old ones are here as well. Atomic energy, atomic waste, Fukushima, what happened there? Look at what's it's an opportunity to look at everything as it's happening right now.
The language you use about systems, I think, is really excellent.
They're all interacting, and they need to more so in a more public way. So, and I think that's really more the larger problem than having to come out with a new technology. It's like, how are we handling what we have already?
And as far as the hope aspect goes, that I think that we're all here talking about this also has to do with systems. That this institute was formed on the realization of interdependence, a global interdependence, a world culture institute, and realizing the interconnections between all these broad systems, whether they're social systems, technological systems, racial systems, economic, whatever they are, that they are working together, and that all of these issues you deal with are big, broad, system-connected issues. So how do we deal? And I think we're still grappling with this question, but it really came up in the late 60s and especially in the 70s, this notion, this realization of global interdependence, the fact that we do have the whole world working in interconnected systems of systems, and that those systems work in layers themselves. So how do we untangle it? When you pull on the string here and something gets untangled over there that you had no idea about, how do we deal with that? And I'm not sure that there's a real... The best book that I remember reading about this was called The Techno-Human Condition. I think it came out a year or two ago. And it really tries to understand systems in a bigger context. It started off actually with transhumanism. These two guys got together and said, we're going to write about transhumanism and really wrap our heads around it. And they ended up going in a totally different direction and really talking about these layers of systems of interaction and how do we function in that world. The answer for them was really that we need to make things what they called iterative. That you can't change things at a big global scale because the systems are so interconnected and so big you just can't. But what you can do is experiment with a social change or a grassroots effort at this level and then hope that that can build to another level. And who knows how that's going to affect this global system of systems. But you might change one system here. And that's really that sort of tinkerer process, which maybe it is part of human, but that tinkerer sort of approach to fixing social issues seems to be the only way that we can really try to affect global change. And so I think it comes back to the fact that we are here at an institute, that this institute exists, that we're all here talking about it, is a step forward. If we talked about, what can an individual do? Some of this does come down to individual initiative. And it's not patting each other on the back sort of thing, but it is important that we're here and that this institute exists for that sort of dialogue to happen.
Jenny?
I was thinking that maybe an historical analogy for me, it's maybe not a very tight analogy, but when I think about this is on the scene now, and I remember just kind of noticing that since World War II, this country promoted so much chemical discovery and manufacture, the whole era of things will be better through chemistry and DuPont. And we had lots of petrochemicals. We had all the chemicals that were used in the war. Then those companies have now become sort of behemoths that are promoting uses of fertilizers and things around the world. A lot of pressure on farmers and a lot of, I think, degradation of the world agricultural system. So just a lot of things played out that I'm not thrilled about. Also the fact that there's so much, the use of pesticides, the use of chemicals that have started to cause a lot of environmental pollution, especially in homes, and invisible, largely. So all those things that have played out, I know that sounds pretty negative about using scientific knowledge and technology to come up with new things that could improve society in terms of, the points Jim is making, leisure, pleasure, and longevity. Many of these things have come into medicine and pharmaceuticals. So then I step back and think, okay, well, maybe I don't really want any of those things, but if I looked at something I would hope technology could help us with in terms of humanity as a whole, it would be cheap source of solar energy. So here's my thought. Here's my question. Do you ever see in these conversations that are going on globally where if people were if they're in groups where they're actually doing planning or thinking in sort of utopian ways about what could be the best next step, you had a set of real scientific advisors or wise people who knew enough about the science and the society to make a plan or propose something. You hear conversations about how to pick a technology that would be for humanity and not so profit-driven. And might it be solar technology?
That's a great question, right? I think in terms of, I'm an environmental historian, and I think in terms of history. So the examples of DDT and chemicals and endocrine disrupting hormones, I think, can be very apt. But again, there's also all the benefits that those chemicals have made to our lives, and some of us wouldn't be here without some of the advances that have happened in that chemical use. So that's the what do you do sort of issue with this? How do you mediate benefits and risks? The issue about are there people thinking in utopian frameworks? Very much yes, right? Like the visionary aspects of nanotechnology were very utopian in some senses, and almost to the point, I would say, sometimes of naivete, not looking at the implications and only thinking of these environmental applications. Richard Smalley, this Nobel scientist who helped really put a lot of public pressure and congressional pressure to pass the National Nanotechnology Initiative in the late 90s, he made speeches throughout the 90s, from 95 on. I have a speech. He's talking to Texas Board of Governors and making an argument for why nanotechnology needs to be the field that we invest in. And it's all about solving global environmental problems. It's about making things more efficient and creating more efficient energy and making it dispersed better, and really dealing with issues of inequality and dealing with helping remove inefficiencies for public betterment, and especially around renewable energy. Energy is a huge component. The Department of Energy is one of the major receivers of NNI money, if not the. So the points you're wondering, are there people talking about this? The NNI is in some ways a result of those discussions. And we're 13 years later, it just so happens that there are implications of us pushing forward to try to realize some of those goals. And so that's part of what the Center for Nanotechnology and the SAINS centers are looking at. What are these implications for these really important goals that can make significant improved changes, not only in individuals' lives, but in the way that our global society works?